Hello, it's Keith here, and this is the third in my Hello World series. This week we're going to be looking at the MSX or the MSX2, basically the same thing from the point of view of what we're looking at today. We're going to see how to create a very simple Hello World example. We're going to learn how to create that as a disk image or as a cartridge image. We'll load up the cartridge, see it working, and then we're going to add some simple monitor tools which are going to allow us to see the processor registers or parts of the system memory. The idea of these monitor tools is that if you're getting started writing a program and you're doing something like trying to read from the joystick, for example, you're going to need to be able to test the results of that and see them quickly on screen. And if your program's not working properly, you want to check if parts of it are getting corrupted and things. And those monitor tools should help you out getting started. So this episode today should be perfect for you if you're starting out on the MSX, but you don't want to follow my normal tutorials and use my development tools, which will do a lot of this kind of work for you, which I totally understand, and this will hopefully help you do that. So let's have a look at the code example we're going to be using today. Now, because we're going to be working on a couple of different systems with disks and cartridges, and because the cartridge needs a specific header file, we're going to have 4 different files today. One for the basic Hello World on the cartridge, one for the Hello World with the monitor, and then a second version of those 2 files for the disk system. Now, the cartridge needs a special header and a different memory address, whereas the disk system doesn't need that header and uses an alternate memory address, at least with the example we're going to be using today from BASIC. Okay. So let's just run the cartridge version here and see it running. Now, I'm using a different compilation script to the one I usually use because the one I usually use puts the header on automatically. So that we can run this ultra simple single file Hello World, including building its own header, I'm using a different execution script today. So you can see the emulator's just starting up here. I'll just fast forward it. And you can see Hello World, and we've hung the processor here. And the reason for that is that we can't return to BASIC because our cartridge system may not have BASIC. So I'm just halting the processor here. You can see that just here. Now, the cartridge header starts at hexadecimal 4000, and there are some bytes here which are the initialization for the cartridge so that the system recognizes it. The first is a fixed header. It's always AB in ASCII letters. And then we've got the address to program start. Now we're starting 10 bytes in because the header's 10 bytes, but we're just doing that by a label here. Of course, that's a word. And then there's some unused bytes for this kind of cartridge, so they're all just 0. Now we just go into our program start here. You've got the bulk of the code, and then at the bottom we've got an org C000. Now we started at org 4000, and this effectively pads the cartridge to 32 kilobytes. Because OpenMSX requires the cartridge to be a multiple of 8 kilobytes, it will technically run it, but it complains, and I don't know if there's other emulators that completely refuse. So an easy way of padding within VASM is to just do this. Now, when it comes to creating our cartridge, this is of course one option. This isn't the option I've typically used in the past. I build the cartridge from components and I use this binary tool function to do the work for me. So what I do is I have a standard header file as a binary, which is effectively this chunk here. I then append the compiled code for my program, and then I pad it using this fill command here. This is binary tools program. It's part of my dev tools that you can download. This is a little program I wrote myself, and I've added a few modules to it to do things like calculate checksums, pad out files with certain data as required. But as I say, you don't need this today, but I just wanted to quickly explain how I do it normally. And this will end up building a complete cartridge. Now, the benefit of this is that this is actually modifying the binary, and because of this, I can copy the same binary into a cartridge and a disk file at the same time if I require. Okay, so that's how we're building our cartridge here. Now let's have a look at the actual code we're running. So first we need to turn on our screen, and we want a 32 character wide screen, and so we're using this system call here to do that. Next we need to set the screen width so that the operating system knows how wide of the screen we want to draw on, because otherwise it would have some borders. So we're specifying 32 here. We're writing it to this system variable here, which will do that for us. And now we're using this print string function, which actually just reads in from our string until it gets to a 255, printing each character to the screen with print char. Well, print char is just using a firmware call at hexadecimal 00A2, and that will print the accumulator to the screen. The final command we're looking at here is the new line command. If we want to start a new line on the screen, which we will probably need to do various times, certainly for our monitor, we just print a character 13, then a character 10, and that does our new line. So our main program code just has this simple graphical initialization, loads the address of the message, the hello world message we're showing, and calls print string. Now at the end on the cartridge we're actually disabling interrupts and halting, which stops the processor. We could do a return if we wanted. But we get this error message because basically once the program is ended, there's no ROM to execute. So it's up to you how you want to do things. Now that's the cartridge version. We also have a disk version. You can see the header is now disabled. We don't need a header this time. We do need a header actually, and we need a header on the disk, but we can do that in a different way. Now we're starting at 810A here. This is the address I use for my program code. You can change it if you're writing your own launching program, but we'll just stick with this for now. The program code is exactly the same, but now we haven't got that footer because we don't want to pad this out. There's no need to. So if we just run this, and you can see we've got a hello world message here. So that's our message, and we are now returned back to basic. And if we do a list, we can actually see the program that did the work of running our code for us today. So what we did is we b-loaded boot.dat, which is the name of this program that we compiled to on the disk. We'll learn how to make the disk image in a moment. Then we define a user call and we specify the address 8108. Well, you should notice that's the same address here. And then we just read in from that user function call, which effectively executes the program. So we created this program here, and if we look at files, we'll see what else is on the disk. Now you can see we've got an autoexec.bas, and that's really the key to this. If we create this little program in BASIC just by typing it in and then save it as autoexec.bas, then the operating system will call that BASIC program for us, and that can load our program, and then we can see the result very quickly. Not as quickly as the cartridge, but if we need to create a disk game, then this is how we can create a disk game and get it running pretty quickly. There's a few other files on here, but they're not relevant. So that's what we're doing here. Well, okay, so that's how we can run our basic program. Let's have a look now at the monitor version. Now we'll just look at the cartridge version because they are, again, identical, just with different headers. And this is based, of course, on the hello world code. We've just got this new monitor command, which will show our registers here. You can see SPAF, BCD, HL, and PC. And if you're familiar with the Z80, which hopefully you are, or you are planning to become familiar, then you'll know what they are. And then we're dumping some memory. We're dumping hexadecimal 8000 here, and we're dumping 32 bytes. And you can see the result of that here. So that's how we can see areas of memory that we might be concerned about, like if our program's malfunctioning, maybe we want to check if it's corrupted or not, or maybe it's not loading into the right memory address or something. It might be important to be able to check that kind of thing. And of course, knowing the register values lets us see if our BC has been corrupted by another function, if our loops are malfunctioning, things like that. Anyway, that's how we can do that. And next, of course, we just need to learn how to create a valid disk image. So, of course, we're compiling our code to a binary first. We're using VASM in these tutorials. There are other assemblers that will work just fine, but I recommend VASM. We're using the old style assembly syntax here, and you can see the command line here. So basically, we specify our source file. I run this from a batch file, so that's this %1 just here. We need a destination file, which is cart.rom in this case, but we can use this for a disk image as well. We just need to do a bit of extra processing in there if we are doing a disk image. Finally, I'm specifying some symbols here. VASM equals 1, build MSX equals 1, and build MSX1 equals 1 as well in this case. Now these are not needed for the hello world example, but the monitor they are quite helpful for because the monitor needs to know what system it's compiling for because it's multi-platform code. If we've compiled a cartridge with this command line here, and of course with this header included here, then we've actually done everything we need, and we can just start this with OpenMSX. We specify our machine type. CBIOS MSX2 Plus is a good basic one because I believe that's free and open source, so OpenMSX by default has that, and we can just start our cart ROM by specifying it here. If you prefer though, you can always use MSX Catapult, and you can just specify the cartridge here or the disk here and select your systems here. But as I say, it's good for getting very, very early started, but you're going to be running your program a lot of times, so you really want to get some kind of batch file or some kind of script doing it for you, which is why I'm focusing on the command line versions. So that's how we can create a cartridge and we can run it. What about a disk image? Well, we saw the basics of compiling our disk image, and you saw, as I said, there was no header as such. We do, however, need to add a header. the header we need to add, we can do with a function I've created called MSX header. This is a program that you can download. It's included in my DevTools, or you can download it from my website. And this will put a valid header onto the disk image. There are a few bytes that are needed as part of the header. There's a magic number, which is fixed. There's a load address. There's an end address, which is the end address in memory, so not the length of the file. And there's an execute address. So if our file is hexadecimal 1000 long and we load it into 810A, the end address will be 910A, and the execute address is probably just the load address in most cases. And then we would have to append onto that header our program code. But of course, this MSX header tool that I'm recommending to you will do all of that for you. So all you need to do is specify a source file, a destination file, and then the address you want the program to execute. And of course, it will inject that execution address into here, and that will just work fine for you. Now, we've made a compiled file there, but that's not actually got it to the disk. If we're using OpenMSX, then we can actually use one of our Windows folders as the disk image itself, which is great because we can just write to the folder and then load up OpenMSX pointing to that folder, and OpenMSX will emulate a disk image from that folder. But of course, if we're looking to release our game at some point or even write it to a physical disk, we might want to create a disk image. And what I would recommend you use for that is a tool called BFI. Now, this is a tool that will take a folder on our machine and convert it to a DSK disk image. You can also use WinImage, but that's not a free tool, and I try to stick to the free tools where I can. So this will convert the folder to a disk image. The only slight problem I've had with it is the boot sector that it creates by default seems to make it stick on some emulators. So what I've done is I've actually formatted a disk within OpenMSX, exported the boot disk image, and then I re-append that every time I use BFI. So using that alternate boot disk, specifying a 720K floppy disk, and then reading in the source folder and specifying the destination folder disk image, and this will create a valid disk image that OpenMSX seems to like. Once we've got our disk image or our folder, we just need to actually start OpenMSX and specify that disk image we're going to use. So I tend to use the Sony XDJ because that's a MSX2 Plus, and so it's one of the best machines, if you will, but it's also a fairly standard machine. And then we just specify the disk image we want to use, specifying disk A here, and then OpenMSX will start up with the disk, and that's all it really takes. So there we go. That's all it takes to get Hello World or any other simple little program working on the MSX. We've learned here how we can create disk images and cartridge images, either just using our assembler or using that little cartridge tool I showed you. Hopefully this will be enough to get you started. If you enjoy this and find it interesting, I've got a whole series of MSX videos, and I've got a whole series of Z80 videos if you don't know Z80 yet. But anyway, I hope you've enjoyed this. If you have, please like and subscribe it. Thanks for watching today, and goodbye.